So let's do some more examples of graphing rational functions without a calculator. So again, here's my game plan, and you'll kind of see me doing it for functions. So the next one, we have x squared minus 4 over x plus 1. So again, I start by finding the zeros, which means I factor the top and the bottom. So when I factor this, this gives us x minus 2, x plus 2, and we have x plus 1. So my zeros upstairs are plus and minus 2, and my zero downstairs is negative 1. So none of our zeros are common, so we don't have to worry about any holes, so step 2 is not necessary. But from step 1, what we now know from our graph is we have x-intercepts at negative 2, 0, and 2, 0, and we have a vertical asymptote at x equals negative 1. So we've got some pretty important pieces of our puzzle just by looking at the zeros, by factoring the top and factoring the bottom. Step 2, as I mentioned, is not necessary because we don't have a zero. The zeros on top are different than the zeros on the bottom. So what about my end behavior? Well, in this case, my degree upstairs is 2, and this is greater than my degree downstairs, which is 1. So we have an oblique asymptote. We've done this one before, but I'll do it again. So we have to do the long division, which can be done with synthetic. And so when we start bringing some stuff down, we get basically x minus 1 plus a negative 3 all over x plus 1. So there, right, is your oblique asymptote. So it's actually a slant one. It's the line y equals x minus 1. So there is basically our end behavior. All right, and then my step 4 is I find the y-intercept at the very minimum. So finding my y-intercept, that's just basically f of 0. 0 squared minus 4 over 0 plus 1. This gives us negative 4. So my y-intercept is at 0, negative 4. So I've got a lot of information here to plot, and then hopefully that'll also give us enough information to figure everything out. By the way, too, down here the multiplicity is 1, so the behavior around the vertical asymptote, which is at negative 1, is basically different, right? It's ripping itself apart. One's positive and the other's negative infinity. Where's my oblique? Well, x minus 1, that's basically a graph that goes through negative 1 and has a slope of 1. So that's going to look like so. So there's our slant asymptote. Okay, and then my x-intercepts, there's one at negative 2, 0, and one at positive 2, 0, and then I have a y-intercept at 0, negative 4. And so if you put this all together with the asymptotic behavior, from here I've got to be going upwards, and in this direction I've got to start hugging the slant asymptote. Over here I've got to start hugging the slant asymptote. I've got to go through that y-intercept, and then I've got to go downwards along the vertical asymptote. And then we've got that multiplicity of 1. The behavior is different on either side of negative 1. And there you have it. Again, if you want to check that with your technology, go for it. But I'm pretty confident in my work. We've got a pretty good sketch of analyzing that function with a lot of neat stuff that we've been learning in chapter 5.4 and 5.5. And so hopefully, again, you see that game plan at work. So again, the next one, same terminology. Let's begin by factoring the top and the bottom. So the top's already is factored, so we know that x equals 1 is a 0 up there. And then down below, I believe if we factor that, let's see, I know that's an x. We need a 3, so I need a 2 and a 1, and I think a minus and a plus. So it looks like down here we have negative 1/2 and we have positive 2. So my 0 upstairs doesn't match any of the zeros downstairs. So we don't have a hole. So step 2 we don't have to worry about. But I do have an x-intercept, right? My x-intercept is at 1, 0, and my vertical asymptotes are at negative 1/2 and 2 respectively. So step 1, step 2 is done. Step 3, what's my end behavior? Well, in this case, my degree is 1 in the numerator. My degree is 2 in the denominator. So my horizontal asymptote is the x-axis, or what we know to be y equal to 0. So far, so good. There's step 3. Step 4, at a bare minimum, I find my y-intercept. And so in this case, my y-intercept is f of 0. Plugging that in, we get -1 over -2, and we get a half. So we are crossing the y-axis at 0 and a half as I was working my way off the board. So at this time, I'm hoping, right, I'm going to go to step 5. All this information should be enough to graph, but if it's not, we'll do more, right? We'll plot some points or whatever the case might be. So here's what I got. My vertical asymptotes are at -0.5 and at +2. So there's where we're not crossing. My horizontal asymptote is the x-axis. Alright, so we've got that. My x-intercept is at 1, 0. So we actually are, in fact, crossing the horizontal asymptote. So that's no surprise that can happen. My y-intercept is at 0 and a half. Alright, so with the information that I have, I know my graph is pretty much doing this. And that's about all I can tell. Perhaps, as a matter of fact, are we coming back up? Are we going back down? We can probably argue that real quickly because the multiplicity is 1 for both of these, and so we can do that. But it looks like I need to plot up a couple more points. So what I would recommend, notice we really don't know what's happening in this area, and we really don't know what's happening in that part of the domain. So perhaps what I do is I point plot something over here, like let's say -1. What is f of -1? So when I plug that in, I get -2, 2 plus 3 minus 2, and it looks like we get -2 over 3. So -1, -2/3 is a point on my graph. So -1, -2/3 puts me here. And so now, with using the asymptotes, I can pretty much figure out what else is happening right there. Remember, the multiplicity is 1 here, so as this goes up to +infinity, that has to be going down to -infinity. So we're pretty much almost done. What's happening over here? Well, again, how about we look at f of 3. So when I plug 3 in there, we get 3 minus 1, 2 times 3 squared, minus 3 times 3 minus 2, that's a 2. That's an 18 minus 9. I think we end up with 2 over 9, 7, 2/7. So 3 and 2/7. So that puts us probably about right there. So again, using my asymptotes, in this direction we better be hugging the x-axis, and in this direction we better be going up. Which now tells me, since the multiplicity of this 0 is 1, this graph is truly going down. So using all the concepts that we've learned, there's my rough sketch of this function. And again, you can verify that with your graphing calculator, but there's my algebra, and my algebra is helping me create the graph. And in this case, my step 5, right, step 1 through 4 didn't give me enough information. I actually had to pull out a couple more points to make me feel comfortable about what's going on in some areas. And that, don't be surprised, that sometimes happens. Good practice to do some evaluations of functions. Alrighty, so how about I cut away from this and we'll do a couple more because we're almost 10 minutes into this. And the last one was a little long, and I don't want this to go much longer. So another video coming soon where we continue to use our step-by-step process to graph rational functions.